luck, ladies and gentlemen. The theme for this session is lightweight strength and high temperature performance for next generation aerospace platforms. To chair this session, we have the very distinguished Air Vice Marshal P.S. Gangopadhyay, VSM, Assistant Chief of Air Staff, Air Headquarters. May I request the Air Marshal to please come up on the stage. We also have a very distinguished panel of speakers. May I request the panelists of this session to come up on the stage. Dr. R.K. Rayudu, Technical Director, Materials Technology, Aeronautical Development Authority. Wing Commander J.K. Sahu, Senior Production Engineer, Indigenization, 12 BRD. Dr. Sanjeet Kumar, Scientist D, ATV Project, DRDO. Dr. Raghavendra Kumar Mishra, UK Research Innovation. Shri Sanjeev Kumar, Senior Sales Manager, Adroitic Information Systems. Shri Lokesh Joshi, Founder, GrowCalp H2CNT. And Shri Balpreet Singh, Manager, Aerospace and Defense, Ernst & Young. Let me introduce the chairperson and the panelists. Air Vice Marshal P.S. Gangopadhyay, VSM. ACS Engineering B, Air Headquarters, was commissioned in the engineering branch of the Indian Air Force in 1988. He is a graduate in electronics and communication engineering and postgraduate in nuclear science from BARC. He is also an alumnus of Defense Service Staff College and has served as Senior Engineering Officer of 2 frontline fighter squadrons, Commanding Officer of a Fighter Tetra, Chief Engineering Officer of an Air Force station in Southwestern Air Command, Project Director of Indigenous Fighter and Trainer Design and Development in ADA and Critical Appointments in Air Headquarters. Dr. R.K. Rayudu, Technical Director, Materials Technology, Aeronautical Development Authority, is a graduate in Metallurgical Engineering and MTech in Metallurgical Engineering from IIT Bombay. After working for 5 years in steel sector, he joined Aeronautical Development Agency as Scientist C in 1999. His major responsibilities involve indigenous development of metallic materials and associated processes required for combat aircraft programs. Wing Commander J.K. Sahu, Senior Production Engineer, Indigenization at number 12 Base Repair Depot, is an electrical and electronics engineering graduate. He was commissioned into the Aeronautical Engineering branch of the Indian Air Force in 2008. Dr. Sanjeet Kumar, Scientist D, Headquarters ATV Project DRDO, is a material scientist. He holds a PhD in tribology from IIT Delhi. His expertise spans tribological systems, lightweight alloys, nanostructured composites, and advanced coatings for wear and corrosion resistance. Dr. Raghavendra Kumar Mishra, a PhD from Cranfield University, is a distinguished materials scientist with extensive international research experience across Europe, UK, and India. His expertise spans nanomaterials, polymer composites, advanced fabrication techniques, and sustainable material systems, recognized with prestigious awards, including the Vishweshwarya Fellowship and Excellent Researcher of the Year. Dr. Mishra continues to pioneer innovations in nanotechnology, composites, and sustainable engineering solutions for aerospace, defense, and environmental applications. Shri Sanjeev Kumar, Senior Sales Manager, North Adroitic Information Systems, has over 10 years of industry experience, including 8 years in additive manufacturing. Shri Lokesh Joshi, Founder, GrowCalp H2CNT, is a pioneering innovator specializing in high-performance nanomaterials. With over 15 years of industry experience, he bridges the gap between advanced material science and practical defense solutions. His work focuses on developing specialized materials for energy storage, stealth technology, and high thermal conductivity. And Our last speaker, Mr. Balpreet Singh, Manager, Aerospace and Defense, Ernst & Young, India, has over 12 years of experience in international business, defense strategy, and policy advisory. He specializes in defense procurement, industrial licensing, and foreign direct investment and joint venture structuring, advising global OEMs and Indian companies on navigating India's defense ecosystem. May I now request the chair, Air Vice Marshal P.S. Gangopadhyay, to kindly take over the session. Over to you, sir.
Good morning to all my distinguished seniors, ladies and gentlemen. It's a privilege to chair a session with such kind of distinguished speakers on the panel. Let me get straight to the point. The best part about such a symposium is that almost all of us will echo the same thoughts, just with different words. Ironically, admitting that we all know the issue, know the resolution too, yet have been waiting, at least till now. This topic may sound shade technical, but in reality, it sits right at the heart of aerospace power. In future aerospace, materials are not supporting actors. They decide the plot. You may have a sleek design, you may have a great engine, you may have smart avionics, but if the structure is either too heavy, if the hot section cannot take the heat, if the coating degrades far too early, if the material life is uncertain, then the platform looks just amazing on paper, but it either fails or struggles when put to direct applications. And military world has seen enough of it already. Why does the topic matter? Let us simplify it. Every kilogram saved in an aircraft or a flying platform means one of the 5 things: more fuel, more payload, more range, more endurance, or just simply more survivability. And every increase in temperature tolerance in the engine nozzles, hot structure, thermal barriers, and high-speed application means better performance, better efficiency, and better durability. Let us be fair to ourselves. We have moved ahead as a nation. We are no longer in an era where advanced materials are discussed only in DRDO research labs or academic journals. We now have visible movement in actual aerospace programs. India's composite work in the HAL and ADA and DRDO-produced ecosystem has shown that we can reduce structural weight and improve efficiency in meaningful ways. CSIR-linked work on composite components have reported over 20% savings and around 25% weight reduction. Certain structural developments by ADA and HAL have shown that the material can tolerate around 200 degrees Celsius. But these have moved into production support with deliveries already made. That's important because it tells us that Indian material science is not just for publishing papers, it is finally begun to produce. At the same time, let us not fool ourselves. We have made progress, but we have not yet mastered the complete chain. We have islands of excellence, no doubt about it, but we do not have a full ocean of capability. The fact is, we are further ahead in airframe composites than we are in engine hot section materials. We are better at structural material substitution, but still struggling at full spectrum mastery of superalloys, single crystal blade, thermal barrier coating, high temperature ceramics, long life hot end materials, and production grade repair ecosystems. This is not negativity. This is plain reality. The aerospace has a nasty habit. It punishes self-congratulation. If material maturity is weak, sooner or later it shows up as delayed programs, lower serviceability, import dependence, restricted upgrades, or reduced wartime survivability. So let us not be impressed merely because something exists in the prototype form. That said, we should recognize that where serious capabilities have emerged. Single crystal blade technology has been developed by DMRL. Similarly, titanium and superalloy, as it was discussed by Dr. Kamath, some production facilities have been enhanced. There is a plant in Lucknow. In October 2025, they have inaugurated a facility which can produce 6,000 tons per annum of titanium. But no aerospace nation becomes powerful by importing the difficult material layers and then celebrating the final assembly. Where it shapes up is now let us come down to what I believe is one of the most important truth of the discussions today. Encouraging Indian private industry in advanced aerospace material is inescapable. As a great president of a nation said, read my lips. Participation of private industry is not desirable, not useful, not welcome, but simply put, inescapable. We cannot build a genuinely sovereign aerospace future by trying to preserve the strategic core indefinitely with the PSUs alone. A nation of India's size and ambition cannot rely on a narrow production model for technologies this complex and this critical. Because there are few desirables which the private industry bring. Few are speed, process discipline, investment hunger, supplier depth, manufacturing competitiveness, and the willingness to scale. And frankly, in some cases, it also brings something else that is very badly needed, a fear of missing deadlines. We have to move beyond the mindset where private industry is treated as a peripheral participant. And let me say it with some humor, though the point is extremely serious. If we keep inviting private industry only after the difficult decisions are over, after the architecture is frozen, after the timelines are missed, and the budget has become nervous, then we are not building partnership. We are simply outsourcing our panic. So where do we go from here? We all know the achievable goalposts. There are few solutions. Firstly, we must move on from prototype success to production reliability. Secondly, India must build the full critical chain of all the materials and the material banks. Thirdly, every major platform should be judged not just by indigenous content percentages. This is a very fairly critical statement. Our product should not be judged by critical Indian content percentages, but by critical material independence. We need to source the rare earths. For that, we may need policy changes, major policy changes, and alter few environmental restrictions. So be it. There is no cost which compares to ensuring sovereignty. Fourth, we need a far tighter bridge between labs, manufacturers, users, and certification agency. And fifth, private industry must be brought into center much earlier, much deeper, and with much greater trust. It was reassuring to hear the harbinger of Indian Air Force future, Air Marshal Yalla Umesh, voice exactly the same thoughts of strategic relevance. There can be